Find the derivative of the function f of x equals 3x squared minus 4x plus 1 at the number a. So we need to find the derivative, which means we need to use the formula for the derivative, this limit-based formula. We've got the limit as h approaches 0 of f of a plus h minus f of a all over h. You're going to be seeing this sort of a limit over and over again, so this is the time to memorize it if you haven't yet. And then we need to plug in our function here. So let's get to it. We need to evaluate our function at a plus h. So that's going to be 3 times a plus h squared minus 4 times a plus h plus 1. And then we have to subtract our function evaluated at a. And we need parentheses here because we've got to subtract this whole quantity. That's going to be 3a squared minus 4a plus 1. It's getting subtracted all over h. And then we have to do a little bit of algebra gymnastics to expand all of this. I'm going to do a couple of steps at once. I'm going to expand a plus h squared plus 2ah plus h squared, but I'm going to multiply that 3 into it right away. So that is going to be 3a squared plus 6ah plus 3h squared, because the 3 is getting multiplied by the a squared, the 2ah, and the h squared. And then we've got minus 4a minus 4h plus 1, distributing that negative 4. When we distribute the negative 3, it's going to be minus 3a squared plus 4a minus 1 all over h. And then it is cancel-palooza. What can we cancel? We've got a positive 3a squared and a negative 3a squared. We've got a negative 4a and a positive 4a. We've got a positive 1 and a negative 1. I think that's everything. So that gives us what? 6ah plus 3h squared minus 4h all over h. We can then actually divide each of those by h. Gives us 6a plus 3h minus 4. And to take the limit, we can use direct substitution. We can plug in 0 for h. 3 times 0 is 0. Those go away, and we get 6a minus 4, which is our derivative.